The Commodore 64 as a learning tool.
Computers are often good in a classroom environment. Certainly there's a lot of excitement in education. Students seem to like computers. Very often the most common thing we see computers used for is drill and practice. The computer puts a question to the student answers a question, then another question gets placed, and so on. If the student gives an incorrect answer, perhaps the correct answer will be shown. This sort of thing is called computer-assisted instruction, which is abbreviated CAI. Now, there are some people in education who feel that the students should not be forced into too narrow a channel, and that the computer has many more uses than pure drill and practice. They like to talk about the general environment where a computer can help any learning process, whether as a supportive device, whether in simulations, whether in even game-like situations. That's usually called by a slightly different name, computer-assisted learning, or CAL. Whichever way you go, the teacher in the classroom now finds himself or herself in a rather strange position. First of all, you have great enthusiasm, great energy on the part of their students. But the teachers themselves feel that it's perhaps difficult for them to learn to be expert programmers in order to deal with the material that they want to teach. What can they do? Should teachers become programmers? Should programmers become teachers? It's not an easy question to answer. The average classroom teacher does have a few things to do. The teacher can buy teaching programs, buy software which can be used in the classroom if suitable material can be found. The teacher can even challenge students to prepare the material and try, let's have a contest and say whoever can write the best teaching program gets a prize. They get to write another one. Something useful like that. You'd be surprised at what a reward that can be for students. And finally, there are some attempts to make teaching or preparing teaching materials on a computer easier. There are specialized languages such as Pilot in which you really don't know how to program. All you have to know is how to go about preparing the material, plug it in, and Pilot will organize the presentation for the students. It's not really programming, it's organizing material. But perhaps once again, Pilot often causes teachers to force their information into too tight a channel. Now, we'll talk about games and simulations and other things that are very good in the learning environment in a moment. But what I'd like to talk about now is that it's probably always best if a student has a large range of options. If a student is simply being forced to put in simple canned replies, there's less interest in there, and perhaps there's less excitement. Perhaps we're throwing away some of the good things the students bring. Let me see if I can show you a simple drill program which is organized so that it allows the student to exercise certain options as desired. This is a simple example of an addition program. We'll say run, and the program says this is a simple addition 4 plus 7. Now here we're using the 4 function keys on the right-hand side of the computer. At the bottom of the screen they're identified. The function 1 is called a help key. If you don't know the answer, you press that key. The question here is 4 plus 7. If we press the F1 key, the answer 11 will appear on the screen, and now a new program is set in there. Anytime we want to try our hand at doing it, 8 plus 6, well, perhaps that's 14. We can type in the answer, and we're identified, yes, it's correct. 7 and 3, we're trying 9. No, that's wrong. And the border of the screen changes color for the moment so we can see visibly that something's happening here. We could also have sound to give us an audible signal that something is wrong here. Now, that's one of the things that we can do. We can ask the computer for the answer anytime we're still trying to learn. We still really don't know how to do this sort of thing. Eventually, we can try filling in these things, and when we get enough right answer, we may say, hey, we're ready for a test. When we enter the test mode, which is the key F7 down here, then we're going to be marked on what we put in. Now, the point that's being emphasized here is that the student doesn't have a single path. If the student doesn't want to answer, he or she doesn't have to. The student can simply say help and get the correct answer. This is the area where they are. When the student thinks he or she is ready, then we can press key F7 and go from exercise mode into the test. There are 10 questions. If we answer them correctly, we'll be marked, and the teacher will be able to see. 6 plus 5 is 11. That one is correct. Now we're at test number 2. 7 plus 7 is 14. That's also correct. If at any time, however, the student feels that maybe it's not time yet, the test is premature, we can always go back. And we can always do more exercises and take the test again later. That's the kind of interaction that's probably good. And this is a very simple one, that the student is in control. The student can say, I want to do more practice, I want to do less. I'm ready to qualify myself and say, hey, I'm ready. But the more options we give people, the more creative a person feels on that kind of machine. And very often, creativity is what it's all about. That's all I want to say about the general principles of computer-assisted instructions. Next time, we'll discuss computers talking to computers.